Hello everyone. Welcome to our latest Novage webinar episode. This week, benefit from the move to Inventor Professional. We will cover the differences and benefits that Inventor Professional 2017 brings over to Inventor. And those are dynamic simulation, stress analysis, mechatronics integration, and a tube and pipe environment. And when I say we, I actually mean Travis Evans, which is Autodesk technical specialist. Travis joined Autodesk in 2010, and he studied mechanical engineering, earning his degree from the University of Utah. And it is there where he first started using 3D design tools as he took part in the Society of Automotive Engineers mini Baja series, designing, fabricating, and testing a one-person off-road vehicle. Sounds really cool. And before we get going, here's an overview of what we do at Novage. Novage is one of the largest online stores for design software. We offer a huge assortment of software solutions that cater to virtually every designer's needs. So put us to the test and come visit our webpage at novage.com for more daily software news and limited time promotions. Also, come check out the Novage blog and follow us on Facebook, Google+, or Twitter. Coming up next week, Character Animation goes live. Live animation pioneer Gary Josh brings 3D characters to life in real time. How does he do it? Well, you will have to join us and find out. Last but not least, today's webinar is free and it's being recorded live. So if you want to rewatch this or any webinar episode in our collection, just head on over to Novage's YouTube or Vimeo channels. And now, without further ado, I'm going to pass the screen to Travis. Take it away, Travis.
All right. Thanks. Just want to make sure that transition worked okay. Can you now see my screen?
Not yet, but we're still waiting. It's okay. Sometimes, you know, traveling all the way from Colorado, I know it might take some time. All right. You have all our attention now.
All right, perfect. Thanks again, and thanks for putting me in the way back when machine and reminding me about what a great experience I had, working in college with that mini Baja series. But being focused with Autodesk for over 6 years now, having opportunity to work in the manufacturing industry as well as kind of talking with our customers, in a sense, being with Autodesk. And that's what I really want to share is with you guys today is the differentiation you guys can get from moving to Inventor Professional. As I was talking, we'd be able to talk about the transition, and so that if you get Inventor today, right, you're going to get Inventor Professional. So we want to make you guys aware of that, as well as give you a little bit of a sneak peek of some, maybe if you haven't seen Inventor in a while or you're on an older release, what are some additional kind of things that are in there, or some of the what's into 2017. So with kind of that, we'll kind of move along and kind of see the agenda. I'll give you a brief kind of introduction to some of the differences, talk about a little bit of what's new, and then I'll hop in and actually do a live demonstration showing you a lot of that stuff that you guys can get your hands on today. So if we think about Inventor Professional, really it is kind of the way that we kind of help to bring the idea of digital prototyping to the market, and we talk about being able to better design and visualize and simulate our products. But a lot of those aspects only come if you have like Inventor Professional. Like, how do you simulate a design unless you have something like Inventor Professional? So we want to discuss those top pillars of items that we can kind of bring to enable you guys to help better design a better world. I mean, that is what we do at Autodesk, and with our partners, and helping you guys to incorporate those types of things. So if you think about a high level, here's the three kind of areas I'll group everything into. Electrical system designs, or tube and pipe. That comes in a flavor that's like to call routed systems, which is kind of the environment there. If I'm routing any cables or any harnesses or doing any tube and pipe manufacturing, right? Those types of things are going to fall into that realm. Then if I need to do like that simulation, right? If I need to analyze kind of structural analysis of how things are working, or do like modal analysis and frequencies and how those come together, or doing some dynamic sim, those are going to fall under that bucket. And then there's a small number of those that benefit from like our mold and tool design, being able to kind of, if you're doing any plastic injection and molding, and actually creating any of those dies, and any of those kind of molds to be able to kind of create that process. So those are kind of the three buckets we'll talk about a little bit more in depth, and I'll show you some of those. We'll mostly focus on kind of the tube and pipe and the simulation because those are the most common ones. We'll show those live. We'll just talk about the rest. So we talk about simulating your design. There's a couple different ways we can look at that with inside of Inventor Professional. A couple things you look at and you talk about trying to simulate. You want to understand, how your product is functioning in the context of an assembly, right? So there's some kind of motion that's inside of there. Well, as I'm moving through that motion, what are some effects that are going to happen? Can I pull up, some stress that are going on throughout there, right? If I actuate an arm and it's have to lift this entire mechanism, and can I understand kind of what kind of stresses are going on there, right? So being able to simulate and use our dynamic simulation tools, dynamics analysis to be able to do that. As well as if I have, just stresses, right? Just static stresses, linear stress analysis. We can do that inside of Inventor. If we need to go above and beyond that, we do have additional tools like Nastran and NCAD that allow me to do like fatigue analysis and those types of things, and go above and beyond just looking at nonlinear material as well. But that would be something with like Nastran and NCAD. So we look at Inventor Professional as kind of a stepping stone to simulation. We talk about some dynamic analysis, some stress analysis, even having some frame analysis inside. They're all kind of static stresses or a little bit of some of that motion. But that's kind of our entry point to simulation within our broad portfolio of simulation that Autodesk has to offer. So that comes with Inventor Professional, but we talk also about kind of the routed systems or the electromechanical workflows. I wrap this kind of two groups. You got your electrical mechanical, where if I'm doing any electrical schematic design and having to kind of integrate any of those wires and connectors and having an automated process to be able to route those cable harnesses and do nail board drawings. Those are types of things we can do with inside the electrical design tool. There's additional benefit, right, if I was looking at like product design suite, if I'm kind of talking about, well, if I want to be a professional versus product design suite, well, product design suite, you also get AutoCAD electrical. And there's a great seamless integration between those two tools. So if I'm creating those schematics in AutoCAD electrical, I can then import that information into Inventor. So that kind of helps you kind of within that process. But if I'm not doing that today, I can manually route those wires and pins and kind of create that information inside of Inventor. But knowing that there's more and above beyond that from a suite perspective, right? We get the whole entire workflow with the electromechanical design with that electrical systems and the cable and harness routings inside of there. If we take that kind of another perspective, right, we talk about tube and pipe. So if I'm creating anything that has any tube and pipe runs and any kind of rules, I want to be able to capture that information. We can do that with our tube and pipe environment. Right? There's the content center you guys are all probably familiar with, and being able to import those important components. Well, not only do I have fixed tubing, flexible tubing, or kind of there's a library of those types of styles that we can create, and with those styles there's different connectors we can determine, right? And I'll show you some of that in the interface. So helping you understand if you do any tube and pipe, it's a very impactful reason why you'd want to look at Inventor Professional. And then kind of the last one, we talk about tool and mold design. So if you're doing any plastic part design inside of Inventor and wanted to take that kind of the next level, maybe you don't have a industry-leading tool like MoldFlow that also Autodesk offers within our simulation package, but you want an entry level to start understanding, hey, where do I put these entry points for this injection mold? Right? So if you want to be able to start to build up what that mold looks like and what the actual tooling is going to be putting that information, creating those cavities and things of that nature, all inside of the tool and mold design environment, right within inside of Inventor. So if you do any plastic parts and you wanted to think about, hey, how can I better integrate this, be able to pass information better to maybe those who are doing my injection molds, or if you guys wanted to take that more on in-house, there's some great entry-level tools inside of Inventor Professional. Again, building upon that, and if you do injection molding, we should definitely talk, because we have industry-leading tool with MoldFlow to be able to help you within that side of that process. But also kind of on that aspect, if you're an Inventor user and you've kind of seen some of the things we're doing in that realm, there's also Inventor HSM, which allows you to actually create your tool paths for any of those CNC processes, right? So if you're starting to think about that world and doing that, not only can you help better design kind of what those mold cavities looks like, but then you could use a tool like Inventor HSM, which doesn't come with Inventor Professional, but there is a tool out there you can kind of get started with HSM Express, but also offering full-blown Inventor HSM inside of, again, an additional package you can add on as we talk about all these different things. Well, what can I get started with? How can I add additional features once you kind of get wanting more? So Inventor Professional is a great stepping stone to a lot of those tools. So that's kind of, high level. If we think again, we got our tube and pipe or electrical mechanical design workflows. We have our stress analysis, our FEA, and dynamic simulation, and then tool and mold design. Those are the top, those are the three reasons why that are different with inside of Inventor Professional. We'll highlight, the majority of the simulation as well as the routed systems portion in a demonstration here in just a minute. But for those of you who hadn't seen Inventor in a while or looking to look at kind of, hey, what's new inside of Inventor 2017, I picked my personal top three to kind of highlight today and demonstrate for you, but there's a great landing page that we'll point you to at the end. You can kind of look for more information on Inventor 2017 and some additional features that are kind of productivity enhancements related and things of that nature. So the first one that I would pick, probably one of my favorites, is Shape Generator. So if you maybe saw 2016 R2, right, we released an R2 and an R3, as well as we have plans for an R2 and an R3 this year. So Autodesk is really changing the way that we're delivering our software, and we saw last year with the 2016 R2 release, it gave us an entry point for this Shape Generator technology, but 2017 saw some significant enhancements and things to be able to help you out. So one thing that we can able to do is we can set these bounding boxes of areas of where we want to keep certain criteria. So as we're letting the computer do some of the design for us, so we're letting it optimize our shape based on our stiffness of the material. So we can let the computer run the algorithm, let it run some feedback, and give us back that information. So we don't have to maybe do a test, simulate it, find out where maybe some low stress concentrations areas are, and then we can take out some material from that point. We can use Shape Generator to do that for us in kind of one full swoop. Some of the enhancements are being able to create these what we call these target regions, right? So you can kind of see here on the screen the little green boxes. So it's like, hey, don't mess with this geometry. This geometry is important because it's where I'm mounting that structure, but everything else, free game. Some other things we heard back was like, hey, you know what, I want to be able to reduce the member size. So as I'm creating this algorithm where I'm creating these components that are attaching in these different webs, right, I'm able to kind of keep something that's more manufacturable, right? So we can be able to keep that member size to a specific, size, as well as going to be able to use like a target mass reduction, as well as a percentage, right? So we said before, if you saw it in the R2 release in 2016, we could do like by percentage, but we can actually do by target mass. So say, hey, I want this part to reduce by this amount. We can set that in there, and we can also add symmetry in here. So as I'm building symmetrical parts, we can have the analysis only return things back as far as their symmetry. So some great enhancements within the Shape Generator technology. If you haven't seen it, definitely should try that out. Other things, so being able to, the way that Inventor handles data. If you're familiar with Inventor, in the 2016 release, we brought any CAD to the workflows and how we can start to work with CAD data that we need to kind of keep references to. But then as we kind of continue to improve that, well, if there's other things you want to do with that data, so like mesh data, right? So an STL or an OBJ, if I want to bring that in. But traditionally inside of Inventor, not much we could really do with it, but now as our product team says, really we treat it as a first-class citizen, meaning I can actually constrain it, I can create assemblies from it, I can use that geometry to project points from, so some great enhancements to be able to help me throughout that process, as well as doing like an interference detection. Right, so actually using smart data to be able to get that information out, and just knowing that there's a lot more ways we can start to handle that data. As Autodesk is, and Inventor specifically is great with the way that we handle the data from multiple file types. And the last one, I think, is something that was very, very high on the priority list from our idea station. It was like, we want to be able to output a 3D PDF. This is kind of the industry standard for being a PDF or sharing documents, whether it be Word documents or sharing any kind of file types, and be able to do that. So kind of have an industry-specific file form that's generic, right? Not just something that's Autodesk, but everybody kind of has Adobe Reader, right? So we're having to require them to, capture that information. But when we did this, we wanted to do it right? So being able to kind of publish that information, selecting the important details that you want to include or exclude. So you'll see some of that in this demonstration as I kind of show you some of these what's new items that happen and be able to kind of publish those out and share those documents. So with that, I think we'll go ahead and hop into a demonstration. I've done enough PowerPoint. Hopefully I've perked the interest enough for each of you guys to hang on a little bit longer and see some of this information in action. So with that, let me pull up Inventor, and we'll take a look. And we'll start with some of the what's new stuff. So if you guys haven't seen Inventor for a while, you want to kind of see some additional kind of feedback, so just kind of help everybody out for those who have Inventor Professional maybe on the call and looking at some of that what's new information. So here I want to highlight kind of the availability to be able to bring data into my data, right? So regardless of where I get that information, right, I can kind of have step, I can have images, I can have all sorts of different pieces that are coming in. But here I simply want to bring in a mesh, right, an STL file. So as I bring in this STL file, the first thing you'll notice, I can actually kind of see, what information is going on. So to help you guys kind of understand this, let me turn on some of those edges so you can kind of see, yeah, we got some STL files. We can also kind of see some relationships that are starting to be built, right? So some third party, right, who translated these data. But previously, we couldn't do much with it. But now you can kind of start to see as we start to think about how we're handling the data. And actually what we can do is I can actually now create those components and use those components to actually generate, assembly information from, right? So constraining those, being able to kind of create, rotational, right? So being able to actually work with data regardless of the file type. So something very impressive that we started to do better with inside of the Inventor product is the way we handle data. So if I want to kind of continue on with that design, maybe make a circular pattern of that, just referencing that information, we have now better workflows we can now enable to actually use that geometry as part of our design versus just using it as a reference. So if I wanted to take this and we can kind of see that now I'm actually colliding that within that clamping structure, right? So if I wanted to do some kind of inspection, I can do some interference detection, which will allow me to actually go ahead and take these specific components. I can take this entire pattern and I can define it against this component, and we can actually run that check and say, hey, you know what kind of information or feedback we can get back? Well, now I can actually get that a total volume of that colliding process, so we can really understand and start to use data better inside of Inventor 2017. So if we take a look at this individual component, right, this little guy here, and we want to take a look at maybe using this as a reference. So maybe we don't want to use that STL file. Maybe we want to recreate it. So what are some workflows that Inventor 2017 allows us to do? So we can take this, we can take a sketch, but as you can kind of see here, now with the projection of this geometry, I can just simply start projecting those lines, those arcs, those edges, and starting to get all that important information right from within inside of Inventor. So I can kind of continue out this sketch and kind of finish this sketch and just kind of to show what else we can do. So here's kind of one that we've kind of created here for you, just projecting that information, right, all that data from here. So if I want to use that as a reference, well, now I could, but now I can actually use sketch geometry that we created from the model to actually create data from. So the ability to kind of reverse engineer, recreate that data, trying to make it a lot more streamlined process inside of here. So as you start to think of like ideas for this type of workflows, and okay, now I can use that STL data to give me a starting point inside of Inventor, because now I can maybe modify this data and actually use some feature recognition tools, right? So if I wanted to take, and do some direct edits, well, now I have this this top face, right? And I can kind of push and I can pull and start to understand, what's going on. I can modify kind of that data. So all starting from that reference point, giving me the capability to kind of start to modify or manipulate data that didn't start as a native CAD file, right? It started as an STL or a mesh from that information. So that's one of those. Right, another one that's very impactful that I think is worth highlighting is so being able to share data and be able to share that data regardless of the tool that the consumer or your customer is needing to consume, and without having to have them have a CAD tool to be able to do that. Well, we can kind of see I've set up different views representations inside of Inventor. So here I have, my welding bod, I have the top head of this unit, I have the complete unit, a couple different views, but I want to capture that information as I share it. So I mean, we can share data all day long. If we talk about, some of the different CAD formats that we could publish out to, there's quite a bit of them, right? So, some of the big players, Pro Engineer, the stat files, the CATIA, the IGES, the OBJs we talked about, and STLs, right? So we can share that information, but if we don't want to share CAD data, we just want to share representations of that. Well, now we can go ahead and we can export this information out as a 3D PDF. And what's great is, with Inventor, we give you some templates. So if you don't have, like Adobe Illustrator, Pro or anything like that to be able to kind of generate your templates, we give you some default templates that you can use. But if you have those tools, you can customize and build your own templates for publication. So what information is included in that PDF? Well, we can include any of those properties, right, with inside of that project. You can see all the entire property list I have access to. Any of those view representations, I can capture those. I can even generate, I can toggle on or toggle on or toggle off the availability to actually provide out a step file that will be associated or linked, to this file. So here I can also include attachments. So if I wanted to take an attachment and share that, with somebody, we could very easily do that and share that information out with them. So we can publish that out, and now we can take a look at kind of those PDFs. So a couple things that we can take a look at, right, as you can kind of see here, well, there's some annotations in here, right? I can kind of, understand what's going on with these annotations. We'll go ahead and we'll create some from scratch. You can kind of see how that information works, but already I'm kind of seeing that I have more access to information than I normally would. Right, so here's a PDF, 3D PDF. I can fully rotate this model, start to understand and kind of see, what pieces of that component highlights here in my model tree. So very familiar interface, like with the information that just came over from Inventor. Here's all my properties. Here's all the colors that were used, maybe specific material or things of that nature, all within inside this data. Also, we can isolate, right, specific instances, right? So we can take a look at just the parts or the components that we have interest in. And we can toggle back and forth, right, between each and every one of those and kind of start to see how everything's coming together all inside of that 3D PDF. A couple other things we can look at, right? We talked about the different views. Well, if I want to look at the robot view, if I want to look at, that initial throat view, right? We can change up the views and kind of publish all that information. So really powerful and impactful in the way that we can share that information with everybody. So now we want to take a look here at additional things, right? So being able to kind of create those design reviews, right? So if I had some great tools in here, so if I wanted to say, hey, what, maybe this base isn't big enough, or we did some analysis on it, we wanted to increase that, right? We could do some analysis, we could do some quick measurements and get some quick feedback. If I wanted to kind of create any other annotations inside of here, so we can add some comments. If I wanted to say, hey, what, let's make this wider by, I don't know, 10%. We can add those details with inside of the project. So not only can we share information better with inside of Inventor, but now given the availability to kind of share and review that data so that the consumers of that information actually can do something with it as well, tracking the information, who was in, who created those details, for really giving us some powerful tools right within inside of Inventor. So that's, two. I got one more I want to show you from 2017, and then I'll show you a slew of different things with inside of Inventor Professional. So the first one we take a look at, and this is kind of what I talked about. One of my favorites is the shape generator technology. So here we have, an assembly. This piece is going to be moving. How is this interacting with inside here? It's got some structural load. It's got to support something, but maybe traditionally, just because of those mounting points, and we just had it as a block because that's what we did. So taking a look at how we can kind of change and leverage that information right within inside of the tool. So we'll take a look here at the shape generator technology, and what it does, it allows us to create more data, right? It's going to create a mesh for us, so we can use then as references to be able to then make better decisions from that information. So that's what we're going to get. We're going to get a mesh that we're going to be able to leverage and then create geometry from, and then choose what we do with it. Okay, so the first thing is, creating any types of simulation. This is one that's kind of great, is because shape generator comes with just Inventor. We talked about you're all going to get an Inventor Professional, but for those few Inventor customers that are out there still, but be able to kind of get right entry level of simulation right inside of Inventor. So with inside of creating any simulation, right, I need to say, hey, I've got some kind of fixed constraint, right? This is going to be bolted to something, right? Because it's being bolted, I can generate that information really quick, really easy. And then I need to say what kind of force. So what kind of force is kind of being applied? Well, maybe the force here, because that top rail goes side to side, I'm applying, 100 newtons of force. Okay, so I've got the entry level for the information that I need. And now I'm just setting up the specifics. Right? The specifics here are, what areas are of concern for me that I do want to maintain. So here, just using a nice little bounding box, nice little triad, so I can kind of start to manipulate this, and I can see, hey, you know what? I want to capture just those initial mounting points, so we can apply that. Right, I can kind of use some of the other different things. We can align to specific material and different things. You can give some radiuses and some different structures. You can start to maintain different shapes. Another thing we talked about was being able to have symmetry. So if I have this symmetrical plane here, right, and I want to maintain this so my part stays symmetric, I can now do that, right? That's one of the benefits of the 2017. And then from this perspective, I want to say, what do I want to do? Do I want to reduce it by a specific, target mass, or do I want to say, hey, you know what, by 25 kilograms, right? We can kind of even say, hey, member size, let's keep that at, 8 millimeters, defining that, and I can, have some great flexibility here with my mesh settings. And so now I've set this up and saying, hey, you know what, now I've got some opportunities for the information I can now share and let the computer do the design for me. So as I go ahead and I hit, run the shape generator, what it's going to allow me to do is going to process that information for me in the background. And just for, demonstration purposes, I have one that I've already ran. But what the difference here is, so you think about traditional ways that we react and interact with inside of there. So traditionally, how I would do that is I'd set that same thing up, run the test, run that linear stress analysis or a frequency analysis, and get some feedback. And then I would say, hey, you know what, maybe we had some low stress concentrations in this area. But then with Shape Generator, it's going to say, it's going to do that for me. It's going to say, hey, you had low stress here, so let's go ahead and let's optimize it and keep optimizing until we get to an optimal strategy. Based on that limit, I said, hey, you know what, I don't want any member sizes that are under 8 millimeters, just for ease of manufacturing, those types of things. We can then leverage that information. So we toggle this view over here to a little wireframe. You can kind of see this is the results you get back from Shape Generator, right? It says, hey, here's this mesh file. Here's what you kind of can start to use is that design. I can promote that to my part level, or I could promote that right to an STL file. So if I was using, additive manufacturing techniques, I could then take that to my 3D printer and add that and create those parts, right, depending on what type of manufacturing we're using. But if we're using traditional subtractive manufacturing, we still have those workflows. So we're going to create a new sketch. And as we mentioned before, as we talked about being able to kind of take and see kind of the different points and things, we can actually go ahead and we can actually create those points and those things from those geometries. So we talked about the capability to be able to use mesh geometry. So if I want to project any of these edges, right? So if I wanted to do a select other, we can now see, hey, here's that mesh edge. So I can utilize that mesh geometry to then just start to create specific features from. And now I can start to say, hey, you know what, let's take this area here. We want to subtract that area. Maybe we wanted to come up here. And we've got this nice little vertex. Let's look at this guy from a front perspective here. Do some more project geometry. We can grab that edge, right? We get close to the edge there. Let's project it. Now we can kind of start to, again, use those edges and things and project that geometry that's from those specific points in that workflow. So I can then start to build out more information. We go, hey, but here's that edge and that point there. We projected that point there. And now you start to build out that information, that sketch, because, like I mentioned, as we talked about with Shape Generator, as of right now, it's just kind of a reference in that data that I can then use and make the decision of where I want to take that out from. But rather than me going through that process of simulating, validating, simulating, validating, taking out some more areas, Shape Generator allows me to do that right for me. So here you can kind of see a sketch that we built right from that geometry. And so now I can use that to kind of create, my traditional kind of subtractive manufacturing techniques. And now we can say, hey, let's cut that out. Let's turn off this visibility here and turn this back to, shaded geometry. Right? So we can start to build this out, use regular modeling technique. We'll use a feature here, we'll mirror that about that face, and now maybe we'll go ahead and add a fillet to this top face. So now we have a piece of geometry that we can leverage downstream, and so from this point, that's kind of where I want to go in, is like, well, what can we do now? Right, so everything I've shown today, that's like Inventor stuff, right? That's just what's new inside of Inventor, both with Inventor and Inventor Professional. You'd both get those, but now at this point, I want to make some additional decisions based on this criteria. I've optimized my shape based on stiffness, but now if I wanted to take that and do an analysis on there, right? So I can enter into my stress analysis environment. And inside of my stress analysis environment, you'll see here, I got my shape generator settings and things that I was able to kind of concentrate from, but I can also go ahead and I can copy those strategies and all that setup I did. How is this part being defined, right? Where is it constrained? What are the forces? I can copy that information, and now we can apply that to either a modal analysis, right, where we can look at some frequency range or some number of modes, or we can look at kind of stress analysis and start to look at kind of what's my deformation and my safety factors. So this is all Inventor Professional, right? So this is Inventor Professional workflow. So if I want to take here, we're doing a modal analysis, right? We can kind of solve that, run that live for you to kind of see what kind of information can I then get back, right? What are some of the frequencies that I need to look out for? Is this part is operating that are going to cause, some problems that we can kind of see here at this high level of frequency, right? Well, we're going to get a deflection of 11 millimeters, 11.5 millimeters right at the top. Is that going to be something that's going to cause problems, right? We can animate that so we can start to see, some of those results. We can kind of see, well, what, based upon the frequency, about 666 hertz, what's going to happen with this? Well, it's going to start to actually delineate and displace, about 11.5 millimeters. So is that going to be something that's going to cause problems? So I need to look at, taking those results, applying those into my designs and seeing how I can kind of change, from that information. So that's one level, right? We talked about modal analysis, but if we wanted to take a look at another type of analysis that we can do right within inside of Inventor is that of a dynamic simulation. So we're going to change views here real quick. Look at my dynamic simulation level of detail that I've set up here. And within this process, right, we can kind of go to the environments. And this is where you're going to see a lot of the new stuff with Inventor Professional. Previously, maybe those things are going to be grayed out that you maybe didn't have access to, right? Tube and pipe, cable and harness, the frame analysis, the stress analysis, the dynamic simulation, all those things are now available to you. And those all happen to sit right inside of those environments, right? So a nice little thing, I've never done it before, never used those types of things. There's some nice little tutorials we can kind of walk you through that information. But what we want to look at here is we want to look at kind of this piston, right? We want to size this piston. We have some motion, right, that this bucket's going to go through. And we can kind of start to look at that. So if we go back into just our regular environment here, we can kind of see that this is how it's being defined, right, the motion and the analysis inside of here. But we want to take that to the next level with, stress analysis and a dynamic simulation. So here let's isolate the specific pieces that we want to look at, these groups, like this piston, this arm, and this bucket, and this little lever. But here we can look at kind of the specifics of this information. I know that this cylinder is going to go through a specific distance. I know what the starting distance is, and I can set that right inside of the tool. All right, so we'll set that to that initial distance, but then I want to actually say, hey, I don't know what the force that's going to be needed to lift this bucket. I could pull from this bucket, I could find its properties and, do the physical properties of this and get all the information, and now I know how much this is, and then I think, okay, now if I'm going to have this at its maximum load capacity, well, what's that going to be? And I can then say, okay, I know what this environment is going to look like. What is the force going to be required to lift, this mechanism? So here we can kind of use some of the tools called the unknown forces, right? So I know the initial position, and I know that my optimal position, the full extent of this front bucket, and we can set that inside of that study. And so now we can kind of get in that output grapher as it plots out the information throughout this process. And so we can start to fully understand as this is moving through a period of time, right, what is the stress that's happening at each one of those points? And it's plotting each one of those for me to be able to use or to reference throughout that process. So something that we can kind of take a start to look at And with inside there as well, if we take a look at kind of, well, what information is also being provided to me. So if you think about the stress, right, that's happening in a specific instance in time, and where is that at, what location is that, and how's that going to affect me downstream. Well, we can take a look at the entire list of properties inside of this grapher. So here we can kind of see what's my minimum stress, what's my average stress, what's my maximum stress. So we can kind of see that, and we can kind of see, well, where are those forces, right? What is that, excuse me, yes, forces. What is that force? And I can start to search for a maximum force that's going to be required to lift that bucket. So now I know I can properly size out that piston. But if I want to take that one step further, and we talked about being able to use that information, we can actually export this out into my stress analysis tool. So we can then take that information, plot it to a specific part, as you can kind of start to see what we can kind of do, and I can say, hey, you know what, let's plot that on this specific part of this assembly and start to see what's going to happen now that I have that force that I was calculated, and now I can leverage that information downstream. So again, that's dynamic simulation, right? That's another benefit of Inventor Professional, to be able to start to look at that and optimize those designs and do some calculations for me. So if we come back to the environments, there was one other one, right? We talked about stress analysis, right? We talked about the things we can do there, both also the modal analysis. We talked about dynamic simulation, but here let's take a look at frame analysis. So frame analysis is another great tool if you're using like frame generator, right? To be able to quickly get some information back. Well, now I can look at frame analysis. So frame analysis, what it's going to let me do is the same kind of things we were just doing before. Set this up, static analysis, and we can kind of look at how my environment's being specified here, so we can kind of see that I want to change this gravity in the correct direction, so that now how is this being fixed, right? So I know that these legs here are going to be bolted to the floor. So I can say, hey, these are going to be fixed at these specific points, right? That's all I need to do. And if I work left to right, like you're familiar with inside of Inventor, I get kind of what needs to happen next. Well, I fix the constraints, I maybe change the initial properties, now I can define some forces, or I can right-click, got those forces right there on my marking menu. All right, so we've got the information there. Maybe now I want to do a continuous load. Maybe we'll even do a various load here. Right. So now I've got this continuous load, and what's happening with inside of that process. So I've set it up. Next thing I need to do, let's simply simulate it, so we can take a look and inspect of what's going on behind this current scene. So here we can kind of see my results, right? I've got my maximum displacement. I can plot my forces and those types of information I can get back. But I can also look at what I like, some of the analysis tools here is I can pick a specific beam member, and I can say, hey, what are my forces in my X direction? What is my moment in my X, right? What is my shear stresses that are going on? I can really start to interrogate my model to understand what's going on throughout that information. So really getting some nice feedback. We can also kind of start to look at the diagram here. So I can say, you know what, let's look at this beam. We can start to see, hey, what does my force look like? Right? And I can display this information right within inside of my model, and we can start to see what's going on throughout that process and how things are interacting with inside of there. And also, if we take a look kind of at the those results, right back at those displacements, we can also probe, right? So I can say, hey, at this specific part in this beam member at this length, what is the maximum deflection, right? Or what is the maximum shear force, right? We can probe the results to get me better information, so I can make more educated results. So maybe I needed to, maybe 4 millimeters of displacement is too much, and I can kind of say, let's put in some more beams and start to redefine that information to kind of help me understand what's going on. Similarly, like with the other tool as well, right? If I want to animate those results to get kind of a visual of what's going on throughout that process, we can start to see that. And what's nice is you'll notice is my probe is telling me what's happening throughout that process as well. So some really great tools to help me understand what's going on with inside that process. And I can even change this to really start to understand, obviously that's not what's happening, but just exaggerate to kind of help prove kind of the points of what's going on throughout those designs. And then I can create some nice reports to share those out with my design team so we can make those decisions. So again, That's one level of information that Inventor Professional gives you, is the availability to do simulation. We talked about modal analysis, dynamic simulation. We talked about stress analysis, as well as the frame analysis tools right within inside of Inventor Professional. Now if we want to take another deviation here and talk about routed systems. So here, working inside of the routed systems, you can kind of see the tube and pipe environment, right? So that's where I'm at. I'm in the tube and pipe environment, and looking and understanding what's going on throughout this process. So here I'm using a series of rules to generate some information. If I want to take this flange here, what place is fitting, we want to add an additional section here in this pipe, right? So now I've got this piece, right, we've started from, and maybe I want to take a junction here. But you'll notice here it's broken up in specific segments. Well, with inside of my tube and pipe styles, we can change any of that information to any of those different pipe sizes, right? So now I'm dealing with a specific pipe style that I'm at. I can look at the styles and what that information means. And so as I'm placing these components, as I'm doing a series of kind of 3D sketches to be able to map that information, well, it's letting me know, hey, well, if I have a pipe, well, what pipe am I using? If I have a 90-degree elbow or a 45-degree elbow or a flange, which one am I pulling from my content center? And then there's some specific rules that we can set in here, right? So I can, hey, what's my maximum and my minimum size? What's the incremental lengths that we can allow in between those? So really setting those up. And as I mentioned before, rigid pipe, tubing with bends, or flexible hose, right? So an entire library of those specific components that you can set up, you can customize and modify and really make them your own. So helping throughout that process, and so now if I have additional components, well, I can go in and I can look, through my content center. So as the content center loads here really quickly, you can start to see that familiar interface you're used to, right? Fasteners and features, or shafted parts, or structural shapes, but being able to pull that information from a familiar interface. But now you'll notice there's a little bit more intelligence, built inside with this tube and pipe design. So here's we grab the specific component we want, and as I go to place this, right, it's automatically going to snap to those components in that specific location. So the other thing you'll notice is once I finish this design, and we rotate this to the 90 degrees that we want, so it's upright to go to that next series. The other thing that it does for us is it'll break up that pipe in two separate segments, right? So here's the pipe. We got pipe 35 and 36 in two separate segments. So it's intelligent enough to know how that was joined. And then because I chose to weld these two joints together, it's going to weld that information in, as I'll show you kind of some of the different styles you can do as well. So now I want to create, a new route. And from this new route, what we can do is I can choose my points. So there's a couple ways we can do this. I can simply just map this out, and I can say, hey, here's my starting point. I want to go here, I want to go there, and then move over here, or I can just choose a starting point, an end point, and let Inventor cycle through some different options. Right? So I like this option, but even if I got an option here and I'm like, you know what, I'd like a little bit more clearance here on this specific things, I can actually take the segments and just simply drag them and move them. And there's been some great enhancements, like I said, with the 2017, with how we're dealing with actually 3D routes inside of here, is to be able to kind of generate that information. And so just from that, I could fully full dimension this thing. So if I want to add dimensions to this, I can control it parametrically, definitely within the realms of that possibility. So helping you kind of see here within that 3D sketch environment, all those tubes and things we can start to generate. So there's kind of tube and pipe, and starting to understand what I can do. But some of the best things here, so now we can actually go ahead and populate that route, and you'll notice it automatically pulled that 45 I specified that was in my content settings, right? Both those 45s, welded those together. If we want to take this flanged fitting here, right, this nice little pump here, place this inside of that segment just to show what else we can do. So based upon what we picked, right, so now I had a flange, and so we brought in another flange to butt these two together. So whether it was butt welded or a flange joint, right, it's based on the components that you're placing inside of there. And that's tube and pipe. So that's one of the other things you might look at. Why would I use Inventor Professional? And probably the last one that we'll highlight here is talking about some of the Mechatronics integration. So you'll notice here there's an electromechanical. So this is more entitled to those who have maybe AutoCAD electrical as well, but all this information is sharing that information back and forth. So, but we still have some great workflows that we can leverage and harness inside of Inventor Professional. So the thing you'll notice is that I can actually pull from that electrical catalog browser. So that same browser that's in AutoCAD Electrical, I have access to that library inside of Inventor Professional. So I can place those components. So like here, this relay here, I can place that from my catalog, and I can then define 3D parts or components inside of there. The other thing you'll notice with these components is if I look at, let's go into this harness, so you can start to see some of the options that come available to me. As I'm looking at this harness design and what information is being populated for me, so I can start to look at what information, what's happening inside of that that workflow. So great things we can do. We can start to route this information, start to pull in the wires and those things from a perspective inside of Inventor Professional. But really what we can do and where this enhancement comes from, so if I'm doing those types of workflows where I need to do route some segments or create some wires, I can do all that inside of Inventor. But if I wanted to optimize that design, I can maybe connect that with AutoCAD Electrical and do my schematic design inside of AutoCAD Electrical, and then push all that information back to me. So now I can start to look at really what's going on with inside of each one of those that information here. So you can start to see each of that information, what's coming through. So working very similar like we did with tube and pipe, we can now define the routes for each one of these segments and just simply add new segments and new parts and new components right with inside of that space. So really great enhancements to look at when you're talking about Inventor Professional and things that it can do for you. So if we do a quick little recap, we talk about the things that we showed. We talked about some of the what's new that comes with Inventor. There's 3 things I showed, how we handle mesh data and how we, can export to 3D PDFs and how we can use Shape Generator to actually do some designing for us, right? If you want to find out more about, Inventor and some of the what's new stuff, I invite you to go to this website here, this Autodesk.com campaign/Inventor, and it'll highlight a lot of the new features that are inside of the Inventor workflows. But then we talked about Inventor Professional and what comes inside of there. We talked about the simulation, both from a stress analysis, from a modal analysis, from a dynamic simulation, from a frame analysis, doing linear stress analysis inside that environment, as well as some of the additional things we showed with the routed systems being tube and pipe and the cable and harness design. Being able to publish that information and really connect the electromechanical type workflows. And then something we didn't show up, we just talked about, was the tool and mold design environment that comes with inside of Inventor Professional. So again, if you have any questions, please feel free to reach out to me. My email's on there on the page now. But with that, I think I'd like to turn the time back over to you.
Thank you, Travis. And this is how you become an Inventor Pro, right? What do you say? I mean, I think this gave you a great idea of what you're getting, what you're gonna get with the move to this Inventor Pro. And you really don't have to do anything. You're automatically move once you subscribe. So I'm looking at the questions. We don't have many questions. I guess everybody's already a pro and they don't need to know anything, but I'll leave you a few seconds if you want to ask away. Travis is here and take advantage of it. In the meantime, I would like to thank everybody for attending this webinar. And I also want to remind you where you can get the new Inventor Professional 2017. Just go to novage.com and you have all the options. You can get it for 1 year, 2 years, basic support, advanced support. It's very easy and intuitive to shop at Novage. And you can also follow us on Facebook, Google+, or Twitter, and check out all the promotions that constantly we put out on our social media, so you don't have to miss any special deal. And I want to remind everyone that our next webinar will be Character Animation Goes Live. And I will encourage you to join us for a very interesting and entertaining tutorial on live animation. To rewatch today's webinar or previous ones, check out Novage YouTube or Vimeo channels. Our webinar playlist has webinar for every software taste, and today's webinar has been recorded and will be posted up there as soon as it's afternoon. So I don't see, oh, wait a minute, we have a question. Okay. Okay, this question is out there about this webinar. Can connect it directly a 3D scanner? I don't know what, I don't know.
Yes. So
Okay.
we have some tools to be able to create that data. So if you have like a 3D scanner, the processing that to create that point cloud information, there's actually some new workflows inside of like Recap, where you can actually take that scan and create that mesh. And then once I have that mesh, I could then bring that STL file inside of Inventor like I just showed you today. So if you do have a 3D scanner and you're looking for those specific workflows, some tools you might want to look at through Autodesk is like Recap, and also kind of keep your ears open for another tool called Remake that's going to be launched here this month. It'll actually work hand in hand with Recap in that space. But yeah, if you're looking for 3D scanning workflows, I mean, we can bring those mesh datas in, right, as long as we can output that. And one of the options we have is with Recap Ultimate, we can actually take that data and export that scan data as an STL file to be able to bring that mesh data into Inventor.
Thank you, Travis, for getting exactly what our attendee meant. Fantastic. We don't have any more questions, and I'm very grateful for a really professional presentation. Looking forward to work with you again, Travis, and goodbye, everyone.
All right, thank you.
Bye.